Due to pandemic COVID-19, we all are is going through a new normal phase, and the team of ICT4SD wishes you a safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at a different level. We at Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience in research activities. To continue further, this conference has received tremendous number of submission, um, which crossed more than 1,000 from more than 20 countries. Out of that, with technical review committee, we were accepted 340 papers, and we were only able to accommodate 160 papers in 2 volumes of the year of this year ICD4SD publication. We once again congratulate your research work to be a part of this success story in fifth version of this conference. And further, I welcome our session chair, Dr. Chaya Jadhav and Dr. Gitika Vyas. We welcome you both, ma'am. Dr. Chaya is Associate Professor at Dr. D.Y. Patil Institute of Engineering and Technology, Pune. CA has total teaching experience is of more than 20 years, apart from University of Pune, also associated with Shivaji University and Vignam University. We welcome you, ma'am.
Thank you, sir.
Yes, we have with us another session chair. Might be she will join very soon. She is Dr. Gitika Vyas. She is Senior Professor at Department of Computer Science and IT, the IAS University. She has more than 12 years of teaching experience. Her area of interests include system analysis and design, management information system, operation systems, quality assurance, software engineering, web designing, and scripting languages. I hope she will join very soon. Now we will start with our technical session. As the details are shared with you, you have a total 10 minutes of time for the presentation. During that time, I will give a permission to share your screen. So that time you can share your screen, you can show your presentation, and I will unmute you. During the time of the whole session, if you have any query, then you can write to the host or co-host. From the chat you can check. So definitely we will solve your queries. So now we move ahead with our first presentation. The first presentation will be by Sunny Prakash Prajapati on an AI-based pedagogical tool for creating sketches representation of emotive product forms in the conceptual design stages. Uh, yes, Sunny, I am unmuting you. Yes, Sunny. Now you can share a presentation.
Thank you, Mir.
Yeah.
Just a moment. So is my presentation visible?
Yes.
Fine. So good afternoon, everyone. I am Sunny Prakash Prajapati. I currently work as an assistant professor at PES University. And my presentation will be on an AI-based pedagogical tool for creating sketched representation of the emotive forms in the conceptual design stages. So this is the overview of the presentation. It has 4 key components. So basically, I'll introduce the theories based on which we have built our model, built our project. Thereafter, the methodology. After that, preliminary validation of our model, and thereafter the conclusion. To start with the introduction, I'll go on and explain the design thinking process and how that is used for any product development as such. So there are many, by the way, there are many versions of design thinking, that are practiced worldwide. But in all of them, there are four key elements. It starts with ideation. It starts with the identification of problems and requirements, then moves to the ideation part, thereafter testing and selection, and final consolidation and refinement. And to stress on the fact that, I would like to stress on the fact that it's not a linear process. It goes on in circles, and and not necessarily one step can leads to other. It can also have certain back propagations, or reverse loops in the whole process. So it's not a very linear, or it's also not a very circular process. That's the whole idea of that. Now, in the product development phase, usually, for any physical product as such, there is uh, form exploration, which is very important for any physical product. And for form exploration in the ideation stage, designers all over the world use sketching as the primary tool, because it's very fast and you can prototype, actually put your thoughts in front of you very quickly. And it's a very versatile tool. And there are technologies that are developed around sketching. So for example, the sketch pads, or Wacom sketching pads that you can see all around you. So now, so sketching is an important part of this whole product ideation phase. And as well as that, it is also used in some other stages as well. But uh, in the early stages, where the sketching is required, is in the ideation of the product form. And when the form exploration happens, it usually the concept is then consolidated, and then put forward to uh, in the creation of any product. Now, in our introduction, we have tried to connect this emotion that is produced from any product to a form. So basically, there are two kinds of theories or you can say there are two kinds of models. One is the discrete model, and one is the continuous model to study emotions. So in the discrete model, we have Plutchik's theory, which is based out of the fact that all the complex emotions are based out of 8 fundamental emotions, and those are listed there. And then again, we have certain models which talks about complex emotion as in the continuous scale. So there we have Russell's circumplex models. And these two models are not the only models, I would say, but they were the first, or you can say the most widely cited models in the area, in the domain. So referring to these discrete and continuous models, what we have done is we have tried to form a map between emotions and words, in the sense that usually designers describe any form using certain adjectives or metaphors. So for example, a cute form, or maybe a very beautiful form, like that. So we use a lot of adjectives. So we have, in the first attempt, we have tried to capture this relationship between words and emotions. And it's also done by many research groups as well. So now, coming on to the methodology, we started with this data set creation. Like I told you before in the introduction, so the data set was all about establishing a map between emotions and certain words. And then relating those words to some line. So basically, uh, line is actually a fundamental element of a design. Through lines, we create shapes, and through shapes, forms evolve. So line is again a very fundamental element. Now, then what we did was we developed a labeled data set of lines using attributes, for example, cute, rugged, and likewise. Okay. After that, in our project, we trained a convolutional neural network we retrained the convolutional neural network on our created data set. And then we moved forward into the smartphone application. Meanwhile, we also did some preliminary validation as to ML model is performing overall. So now this is a little bit detail regarding uh, go how we went about creating the data set. So basically, we had a lot of uh, samples of line drawings which we captured in MP4 format. Thereafter, we sampled various images, a lot of images from that video using FM MPEG tool. Now, this tool allow a video file or a video format to be sampled at a certain sampling rate so that we can get a lot of images from a single video. Thereafter, we did some image processing in order to reduce the noise in our data set. So the idea here was to get a clean or a clean line in an image. So we did some, and the purpose for doing that was to improve the efficiency of the image classification model that we were about to train. And the platform on which we retrained our model was TensorFlow. So we already had a trained ML model or trained image classifier. We just retrained that classifier based on our data set. So for training, we used cross entropy function as a loss function, which was to be minimized throughout the training. And initially, we tested or we retrained our model on two attributes, which was rugged and cute. So basically, all our line items were either labeled manually as rugged or cute. And at the end of the training, at the end of the 500 steps that we trained the network for, we achieved the accuracy of 79.8%. This was, by the way, the testing accuracy. Training accuracy was 100%. So now, after we trained the model, we deployed it in a smartphone application using Android Studio. But before that, we also worked out what the application would do on a larger scale. So while developing applications, there were two things that we thought about. First is the evaluation part of it, and the second one is the feedback. So in any pedagogical process, especially in design, there is evaluation of the form, or evaluation of the things that you have done, and then again there is a feedback on based on that evaluation. So basically, we try to capture these two things through the smartphone application. So evaluation was based on the attribute score of the sketched representation, and feedback was again based on which selected attribute the user wants to intensify in his or her sketched form. So the whole idea of the whole workflow of this application is something like that. So you have a sketch in front of you, you take uh, its image, and then based on then basically you choose a category of attributes against which you want to perceive that form as. And then the image classifier that we have retrained will give you a score based on its evaluation, based on its analysis, and then based on that score we can say which attribute fits the representation better. And let's say if you want to improve upon a certain attribute, or let's say lessen certain other attributes, then then the application will also provide, the ways and means by which you can do that. So in front of you there's a screen, there's a task flow which details out what I'm just trying to say. uh, Now, for preliminary validation, we took 11 forms, or you can say 11 shapes that represent forms. After that, we tested these 11 shapes, or we put those 11 shapes into the CNN and got a attribute score for each of them. After that, we compared the classification result with
Hello.
that.
Sorry, Sunny, but can you please make it quick?
Yeah, sure,
Thank
sure.
you.
So this was the evaluation thing. We just did evaluation using our CNN network, CNN model, and then we evaluated the classification based on for, from a veteran designer as well. So we compared those two things. So this was just for a preliminary validation. And after that, we have also proposed in this work how this thing fits in the overall process, because there is a novice designer there in place. There is this tool that we are proposing, and there is again a veteran designer who usually conventionally is involved directly with a novice designer. So here we are proposing a tool in an overall framework that that will enable the novice designer to learn and develop his her capacity to generate forms of certain emotions. Now, to conclude, I'll just say a few points that we are trying to intervene in the ideation and consolidation stages of the design process, the whole product design process, with an aim to build a pedagogical tool that is based on AI. And such kind of systems are, as you might be knowing, that is built upon the data, a lot of intensive data. So that has also to be integrated in the whole model. And here the human mentor is the key element of the whole system. We are not proposing a tool that works as a standalone thing. uh, one of the reasons is due to the fact that design trends change most of the time. So you have to be that has to be in collision with a human mentor. And this again can be a roadmap for a data driven design approach altogether. So with that, thank you everyone for listening. And yeah, that's it from my side.
Okay. Okay. Sunny,
Yes, ma'am.
good presentation. So, what type attributes the selection? How again it will be done? Attributes.
Sorry, ma'am. Can you please repeat the question?
Attribute selection.
Yes, yes. So, ma'am, attribute selection is basically done on the basis of how we perceive a line, basically. So whether it is more of an aesthetic attribute rather than a functional attribute, I would say.
Okay. Okay. Good. Thank you.
Yeah, thank you,
Okay.
ma'am.
Yeah.
Next.
Yes. Gitika, ma'am, do you have
Yeah,
any question?
yeah, I just wanted to know that what was the criteria behind selecting only 11 sketches for validation or the sample size that you're taking? Is there any formula that you are following?
No, ma'am. There was no formula as such. we have trained the network for over 1,000 samples for each attribute, but
Mm-hmm.
this validation was to see in line whether the prediction by the neural network model is
Mm-hmm.
aligning to the veteran designer, or any designer's perspective or not. I mean, it was just a preliminary validation.
Okay. So if you include this in your research or somewhere, so it would be safe on your part if you have a formula behind which works as a support for your sample size selection. That was a suggestion from my side.
Sure.
So you can just take this in note and look on it. Nice
Sure.
presentation, otherwise.
Sure, ma'am. Thank you.
Okay, thank you, Sunny. If anyone has any question, you can write into a chat box. Uh, so, so thank you. We are moving ahead with our next presentation. Um, we have our next presenter with us, Jay Kotzer. She is presenting her paper on division, a novel means of introducing collaborative decision making to an automated water bottling plant to study the impact of positive drift.
Good morning, everyone.
Yes,
Can
good
all hear
morning.
me? Can you see my presentation there?
Yes, we can hear you and we can see your presentation. Please go ahead.
Okay, thank
Yeah,
you.
thank you.
My name is John Kutzer, and I'm going to present to you the devising a novel means of introducing collaborative decision making to an automated water bottling plant to study the impact of positive drift. I'll just have an introduction, tell about positive drift, what the water bottling plant is, and then how we are introducing it, some preliminary results, and a conclusion. Now, the successful operation of, sorry, I can't see my presentation here. Sorry, just a moment. It's of automated systems are highly dependent on the human technology interaction, as well as the efficient collaboration between the workforce and the automated system. Now, collaborative decision making is used to facilitate efficient science-based decision making. Problem that is found in production processes is positive drift. And this research is going to look at devising a means of introducing collaborative decision making between the human and the machine in the production process to reduce the impact of positive drift using a case study of an automated water bottling plant. Sorry, I'm having some technical. Okay. Just to introduce positive drift in an assembly process, cycle time refers to the amount of time allocated to accomplish a certain process. And then deviation from the optimal cycle is referred to as drift. The drift can be positive or negative. And positive drift is the time span in which the cycle time exceeds the prescribed time. We are doing a comparative study to determine the impact of collaborative decision making on positive drift in the water bottling plant and see what the impact is by comparing an automated process versus a collaborative approach in the water bottling plant. This is a 3D model of the existing water bottling plant. It was modeled in Simulink and optimized using MATLAB as part of the technical feasibility. The plant is split into 3 sections. Subsection A contains the water source, B is for bottle storage, and 3 is for the water filling unit. The orders are placed online by customers. Sorry, I don't know why it keeps on going on. And then we have an optimization model that executes the orders. The model is executed using 3 smart manufacturing units driven by sensors and PLCs. And this system is fully automated. Now, to introduce collaborative decision-making to the water bottling plant, you will see we are, I'm so sorry about that. We have a model here of the water bottling plant, and we have implemented a SCADA, supervisory control and data acquisition system, human computer interaction interfaces, and the 3 SMUs. Now, the HMI is used by the human operator to directly control the processes in the plant, and the speed of the production can also be controlled by the intervention via the human interface. The SCADA introduces or creates an alert when certain conditions or constraints are met, such as the water level and when it reaches a certain point. And the human operator can then make a decision using the HMI to continue with the process or speed it up or slow it down or stop it. Now, our preliminary results. Figure 3 shows a decision diagram indicating the operation of the water bottling plant in automated mode. HMI1 is connected to the SMU1 for filling of bottles, and there are flow sensors and water level sensors that monitors the flow and the water level. Alerts are created when the water level reaches 50% and 25%. The production stops when the level reaches 25%, and then the water must be replenished, and up to at least 75% when production continues again. If you can see in this diagram, the time to fill the bottles or a delay was at 441 minutes when the water level was at 25%. Another variation happened when the water level was at 75%. And the process automatically gets halted when the water level reaches 0. So this is a fully automated process that happens here. Now, to add the human-machine interface to the system, we are going to vary the flow rate, and the test is designed to compare the production time for an automated and a collaborative operation for filling 5,000 bottles. In this figure, the collaborative approach was split into 2 processes, a fast approach and a slow approach. And this indicates that the fast approach, where the human can intervene using the HMI, filled the bottles in much faster than the automated process. Even when we introduced a human-controlled slower operation, we still filled more bottles than in the automated process of the system. So this proves that for this specific section of the plant, positive drift can be reduced considerably by introducing a collaborative decision making process. So the purpose of the research was to determine the impact of collaborative decision making on positive drift in an automated production environment, and to test the effectiveness of collaborative decision making. Two scenarios were tested, the fast and the slow approach. Both these approaches were compared to the automated approach. And the test showed that in the specific case, the collaborative controlled approach was faster than the automated approach. But this only applies to one section of the plant, not the entire functioning of a plant. So future research, we will measure the impact of introducing the collaborative controlled approach in different sections of the operation of the plant to see the impact that it will have on positive drift. There's just some references that I refer to, but there are much more that's available in my paper. Yeah, so thank you for that. And I apologize for my slides keep on continuing without me wanting them to. Thank you.
That's fine. Yes, Dr. Gitika and Chaya, do you have any question?
Yeah, I wanted to ask that what
Yeah.
are your strategies for taking up the challenges of collaborative decision making? Are there any challenges of collaborative decision making? And if yes, what is your strategy to take them up?
The challenges at this stage is we have to determine where the collaborative decision making process will be or have the best impact on the assembly process or the whole production process. It's not to say that it will be the best at each unit. So we are trying to determine where it will best fit for the collaboration with the automated system. Don't know if that answers your question.
Okay, thank you.
Okay, thank you.
Is there any software constraints while implementing this thing, Darsh?
Software constraints.
Yes. You are implemented in MATLAB, no?
The MATLAB and the Simulink
Simulink.
Simulink is not part of my study.
Okay.
Part where I will, or where my software comes in is at the human machine interface and the SCADA
Okay.
thing of that.
Okay, thank you.
Thank you.
Yes, anyone have any question? Okay, so now if there will be a physical conference, might be at the end of the session we will clap or something, but in Zoom also we have one facility. In the bottom you can find reaction, so from there we can give at least a good reaction to presenters. Thank you. Yes, yes, thank you,
Thank you so
Jana.
much.
So
Thank you so
now,
much.
yeah, so now we are moving ahead with our next presentation. Our next presentation is Ajit, and she will present a paper on uh, graphene-based wireless power transmission, charge as you drive. Yes, Ajit, you can say your presentation.
Hello.
Yes.
Yeah. Sorry. Yeah, one second. Yeah. Can you see my screen?
Yes, we can see and we can hear. Please start.
Yeah. Good afternoon, everyone. I'm Ajit Bijapur. I'm doing my engineering in Keli Technological University, Hubli, Karnataka. It's pleasure to be here in the conference. Today, I'm going to explain one of the research work towards the graphene-based wireless power transmission as a charge as you drive. In this presentation, we'll discuss why we need electric vehicle and also what are the problem the electric vehicle are facing and what are the possible solution for that. We'll discuss one by one in upcoming slides. And we know that urbanization has made the world roll on the vehicle, and human is now completely dependent upon the vehicle. And also along with the increase in the vehicle density and the emission and the harmful gases in the environment will also increase.
Hello,
And
Ajit, sorry.
yeah,
A little bit voice is very high, little bit slow.
yeah, sorry. Yeah.
Yes, fine.
Uh, to reduce that, to overcome this problem, to save our environmental, the concept of electric vehicle has been flourished nowadays. The electric vehicle is boon to us also have some sort of problems like battery capacity and the charging problem, etc. We'll see some of the lot of problems in electric vehicle, and we need to discuss we'll discuss one by one what are the electric vehicle are facing the problems, and we'll discuss what are the solution for those problems also in upcoming slides. And we need to know that what is electric vehicle. Electric vehicle is an automobile which is propelled by a one or more electric motor using energy stored under rechargeable batteries. This is what we call the electric vehicle. And we know why we need electric vehicle, because due to increased large amount of carbon dioxide which we cause the global warming and increase in the fuel rate, and acid rain causing due to a release of sulfur dioxide, and health issues due to air pollution. To reduce all these problems, we wanted electric vehicle to reduce this type of problems which we are facing currently. Then what are the problems actually the electric vehicles are facing, like affordability, range anxiety, and the charging station. Affordability is nothing but the battery technology is expensive, because the battery need to hold a large amount of charge to travel from long distance. So that battery that type of batteries are very expensive, so the common people can't afford that type of battery. And the range anxiety is like nothing but electric vehicle can travel up to 100 miles, approximately 160 kilometers on a single charge. It can't go further on an average, because the battery will drain out before it's reaching its destination. And the charging station is like a non-availability of the charging station infrastructure in the public places like petrol pumps. We'll not see that type of charging station nowadays. This is the major drawback of that electric vehicle also. And for one complete charge, the electric vehicle will take 5 to 6 hours to complete its charging. And these are the problems actually what the electric vehicle are facing. To overcome or to solve this problem, we are coming up with an proposed approach like wireless charging. Wireless charging is a method of charging the battery without use of cable or physical connection with the specific AC adapter. Essentially, wireless charging uses electromagnetic field to transfer the power from transmitter to receiver, and also it's called the inductive coupling. This is what we call the wireless charging. Wireless charging usually use the principle called magnetic resonance coupling. In the magnetic resonance coupling, we use this two coils like a transmitter and receiver have some same resonant frequency, and it enables a high efficient and energy transmission over a long distance and compared to inductive coupled scheme. This is what we call the magnetic resonance coupling. And here we need to power up the transmitter, right? For that we are using that graphene based solar panel to power up the transmitter. You may ask like why we are using that graphene only, because the graphene have some particular specifications, like a particular one interesting fact, like it is a thinnest material, and it's a good conducting and optical clarity and a high strength. Also it uses to improve the efficiency cell. Also it can extract the electricity from rain drops. Unfair weather conditions like snow has no effects on load capacity during that unfair weather condition. You may ask like we can use that so normal solar panel, like right? We can't we can use, but you observe that in normal solar panel we use a metal strips are present which we use to conduct the DC electric power. But the thing is like it will not cover all the area, and it will resist or it will block 5 to 10% of sun rays, and it will not produce the desired electricity uh, whenever in the unfair conditions. This is why we are using that graphene based solar panel. And this is our approach to solve this problem. This is how we wanted to build this wireless power transmission. for the electric vehicle. In this system, we divide the system into two subsystems. Like one is power transmitter system and other one is the pickup system. Power transmitter system is the charging unit that transmits the power by electromagnetic field from the grid. From the grid, it consists of a transmitter unit, and these coils are installed under the roads that will transmit the power to the receiver. And we have the power supply unit also, which will supply the power to the transmitter. And other one is like a pickup system. Pickup system is like nothing but a receiver system, and the receiver coil which is placed at bottom of that vehicle, whenever the transmitter and the receiver coil come into a contact, it will start conducting the power. And it's also the vehicle have auxiliary units at the bottom of that vehicle, like rectifiers and regulators, which transmit the power from pickup to the pickup power to that motor and battery. This is how we wanted to build. Like we can see that power can be transferred to the battery without significant energy loss also. It have a efficiency like 50 to 90% of that efficiency we can observe. And this is how we want to install all the coils in the road. This is how the mechanical design we did. And the transmitter receiver coil is a 60 centimeter wide, and the transmitter coil and the surface of that road has a air gap of 20 centimeter in between them. This is the experimental details. And right now we did in the lab environmental field only, instead of going that real-time implementation. Like we did two type of circuit, like a transmitter circuit and the other one is the receiver circuit. In the transmitter circuit, we used mainly components like a 555 timer counter and the MPN transistors, and the other one is like a MOSFET. And using all those components, we built the transmitter circuit, and we are using that 2030 copper gauge magnetic coil, and we are able to receive the power from the transmitter to the receiver. And these are some of the experimental results we got. Actually, you can see that in the first table, we analyzed the output voltage by considering the transformer output, rectifier output, and oscillator output. And you can see that the actual value denotes that voltage measured by the performing while performing that experiment. And you can see that the actual value is close to that theoretic value also. And efficiency is also calculated using this below formula. And you can see that as the distance increases, the efficiency will be reduced. And while we conducted these results we have taken. And apart from that hands-on experience, we also did some of the simulations in MATLAB also, while creating spiral to spiral, like creating transmitter receiver coil for the power transmission. And we also draw that transfer and distance versus frequency graph also we plotted. And other thing is like coupling mode. When the transmitter and receiver come into a contact, how the coupling mode will react, and these many things we did in the simulation part in the MATLAB also. These are the results which we got while doing in the lab environmental. And this like wireless charging is we know that wireless charging is a highly initial cost, and it's a one-time investment. We using this wireless power transmission, we can solve many problems, like reducing the time spent on recharging, and we can travel for a long distance also. And we can use a small battery instead of that high cost battery also. We can save the power also. Energy crisis can be decreased. In the future, the world would be a completely wireless also, I think. Like these are the reference, and this is
Okay, thank you.
Thank you.
Yes, any questions?
So, have you considered the cost for designing this?
Actually, ma'am, we are still in the lab field, no, ma'am. We want to implement in the real time, but we are working in this project in the college level.
Okay, and regarding the safety issue?
Yeah, ma'am, it's completely safety, ma'am. The radiation will not harmful to the humans and the vehicle.
Okay.
Yeah.
Okay.
Fine.
Okay, thank you.
Thank you.
Yeah. Thank you, Ajit.
Yeah, ma'am.
Yeah, so now we are moving ahead with our next presentation. It will be presented by Girisha. The Yes, Girisha, you can start your presentation. The paper
Yes, sir.
title,
Okay.
is Vision-Based Driver Authentication and Alertness Detection using HOG feature descriptor.
Is it visible, sir?
Yes, it is visible and you are audible. You can move.
Yeah. Okay, sir. Thank you. Good afternoon, everyone. My name this is Girisha HM from KLE Technological University. I'm going to present the work we have done in the field of uh, ADAS application. It is a vision-based driver authentication and alertness detection system using HOG feature descriptor. The presentation outline includes that is introduction to the uh, diver safety system and problem definition, motivation to this work, and what are the different measures, the way we can detect the driver drowsiness, and system architecture, some of the test cases and its results, and conclusion of this work. We'll move on to the introduction. Nowadays, the road accidents are very common day-to-day life. Nearly 3 lives we are losing for every minutes, and it costs 3% of the GDP in India every year. So the another based on some survey, we can look into that. There are different cases, reasons behind the road accidents. Out of those reasons, the mainly 40% of the critical accidents are due to the fatigue. That means the driver, due to the driver mistakes, most of the that is what 40% of the accidents happens day to day life. So the another thing is the comparatively we can say that the drowsy driving is more dangerous than drunk condition, as well as we are using a phone while driving. So based on this motivates us to develop a system which authenticate, as well as it will alert the driver when suppose if the driver is in drowsy condition. That is what the motivation behind this work. Then what are the different way we can detect the driver drowsiness? There are no, from the literature we got to know that there are two ways we can solve this problem. The first one is vehicle based measures, the second one is the behavioral measures. When it comes to the vehicle based measures, this monitors the vehicle's position, then how the way the driver is driving the vehicle, what is the steering wheel. This is the main important measures, the way we can identify the driver's condition. But the thing is, it has some advantages, non-intrinsic and accurate performance. But along with the advantages, some of the major disadvantages related to this technique is this measures requires geometry of the road. Some uncertain necessary alert should be given to the driver. And in India, the roads are not always same there, and the driving style will be all different. So these are the some of the constraints related to vehicle based measures. Second method is there is behavioral measures. Behavior measures, it includes the driver's behavior while driving, how what is the rate of eye blink, how is it in the awning condition, or amount of eye closure and position of the head. These are the some of the parameters we can consider to measure the driver condition. So the advantages, this is also an accurate method, and it is more important is real-time monitoring. Therefore we are compared to these two, this behavioral measures is better, and we are take up this method to detect the driver drowsiness. So the system architecture, mainly the input to the system is the driver condition. We are using it is a vision based, so the camera is using we capture the driver image using a camera, And once we captured the image, we are processing that using there is an image processing unit, some image processing techniques we are using to process the image, and some machine learning algorithms in just the classifiers we are using to classify the drowsiness detection. So then once that is the output blocks are, there is a speaker and the mobile. There is, because this system has the two parts. One is to detect the drowsiness. Another one is feature is to authenticity, the authentication of the driver. If the driver is authentic or not authentic, that will be sent to the particular registered mobile number. So the flow diagram of face authentication: first the input image or a video in the form of video, then first we will resize that input image. After that we will convert the color image to grayscale image. Then we are using hog based face detector. We are using, this is the histogram of oriented gradients features we are extracting from the image to detect the face. Then we are encoding the images, then we are comparing. Once the encoded back, we will compare the image with the driver with the data set which is stored in the memory. If it is matched or not matched, that message will be sent to the particular registered mobile. Then the flow diagram of drowsiness detection. This is once it is the person is authentic, then he can start the vehicle. Then we are the next algorithm, that is the drowsiness detection algorithm, will work. This will the process is same, the grayscale conversion. Then hog features is features are extracted. After features extraction, some of the major parameters we are considering: uh, left eye, right eye, eye aspect ratio, mouth aspect ratio. These are the parameters we will calculate. Then we will put some threshold. Based on the threshold, we will classify whether the person is drowsy or not. So the main concept behind this drowsiness detection is the histogram of oriented gradients. We normally call it as HOG features. So first steps, gradient computation. Then the gradient basically is which is used to find out the intensity variation in the particular direction. To find out that, we use the gradients. So the histogram based gradients we are using to compute the intensity variation to detect the faces. Next one is we normalize those features. We will apply the support vector machine to classify the faces. So the advantages works well for the frontal face detection, and lightweight model compared to CNN or some different algorithms can be used for this. And one constraint is minimum face size for the detection is 80 cross 80. That is the minimum size should be. If it is less than that, the efficiency of the detector will be less. Therefore, the minimum we have to maintain the images, our captured image should be 80 cross 80. So the mathematical model behind some of the parameters, that is eye aspect ratio. The eye aspect ratio is so based on the HOG features, we will formulate some of the points, which are the points related to that is P1 to P6. Based on these points, we can calculate the eye aspect ratio. Then there is one more parameter is blink detection. The blink detection is calculated by left eye aspect ratio plus right eye aspect ratio divided by 2. Average of these two eyes we will take. Next, similarly, the mouth aspect ratio, which is calculated based on the points from P1 to P8. Using these points, these values, we can calculate the mouth aspect ratio. Based on that, we will based on these parameters, we put some threshold to detect the drowsiness. The first one is eye aspect ratio, it is a 0.2. Mouth aspect ratio is 0.58, and eye aspect ratio frame count is 15. Mouth aspect ratio we have taken 5, and the resolution of the processing image we have set it fixed it as 500 cross 500 pixels, and the processing frame rate is 30 frames per second we have utilized. Then to test, we have come up with some of the cases, normal conditions while as the driver follows, that is the driver may be awake, the face is detected, then the driver is wearing glasses, it may be some of the eyes are blinking, eyes are closed, some situation maybe driver is yawning and eyes are closed and yawning, the driver is tilted, and there is no face is protected with some obstacles. Then in some cases there is a illumination problem, low illumination. These are some of the cases we have formulated, and we have created the database in such a way that which covers all these conditions. Now, coming to the results, that's what I mentioned previously. All these conditions, the database we have created, and we can look at this. In the first case, it is a normal
Sorry,
condition.
sorry, Girisha, but please make it quick and just go
Oh,
towards the conclusion and the results, please.
yes. Okay. I'm already in the results. Okay. So in the seventh image, you can see that the drowsiness alert, the some case yawning condition, all those images, and along with that, notification will come to the phone, whether it is an authorized person or unauthorized person. From this, we can conclude that this work provides a software solution for real-time authentication and drowsiness detection of the driver based on face recognition algorithm, and it aids the drivers to stay alert while driving. And the proposed framework provides information to the owners about the driver authentication through SMS alert. Okay, these are the some of the references we referred in this book, and thank you. That's it. If you have any questions.
Yes, thank you.
Thank you, sir.
Yes, any questions?
Just one question.
Yeah.
Have you considered which type of vehicles? Is a public transport vehicle or a private vehicle or some truck drivers and everything? So that will be the different types of conditions again. It will be there.
Yeah, ma'am. Actually, in this book, actually we have we in our automotive laboratory we have a lab setup, the car setup, where we have in laboratory we have created the data set.
Okay.
In real time data, we have not yet captured.
Yes. Okay.
Still, that is the we will looking forward to create, and we test for a real time data.
Okay. Good, sir.
Okay,
Okay.
thank you.
Okay, thank you.
Thank you.
Okay, yes. Now it's time for reaction. Just a quick reaction for Girisha. Thank
Hello.
you.
Okay, thank you, sir.
Okay, so now we are moving ahead towards our next presentation. It will be by Philip Serrano. And the presentation title is SIGS was V2 Enhanced Student ID Generator and Management System. Yes, Peng, up to you.
Thank you, sir. Can you now see my presentation?
Yes, we can hear you. Yes.
Good afternoon, everyone. I'm Philip Alger Serrano, and I will be presenting our paper entitled Enhanced Student ID Generator and Management System. Electronic ID systems in educational institutions have enhanced technologically the use of information identification systems. To utilize this advantage, an automated generation and management of ID cards was developed. In its implementation, however, it was found out that the system lacked capabilities needed for a more effective process. So an enhancement was required to improve the system's capabilities. To broaden the
ಹೌದೌದು ನಿಮಗೆ ಬೇಕು ಬಿಡ್ರಿ ಹೌದು ಸರಿ ತಗೊಳ್ರಿ ನಾನು ಲಾಗಿನ್ ಆಗ್ತೀನಿ ನಿಮ್ದು ಇದ್ದಾಗ ಎಷ್ಟು ನಿಮ್ದು ಓಕೆ ಓಕೆ ನಿಮ್ದು 4:30
Sir, someone thank you, sir. To broaden the appeal of electronic ID cards, some establishments have combined the cards with other services and extended.
Sorry, Peng.
For example, several IDs issued in universities also serve as library cards, cashless payment card, computer lab access card, and other electronic-based transactions. Camarines Polytechnic Colleges, as a higher education institution, has been on an upward curve to adopt technologies to streamline some of their important operations. In 2014, Student ID Generation and Management System version 1 was developed and deployed in the college. The system generates electronic ID, which is used by students to link their information to a number of information systems such as the enrollment, enrollment of student information system, and queuing system, among others. However, implementation of the system revealed that it had many inefficiencies in its process. Hence, there is a need to redesign the system to provide a more robust solution in generating and management electronic IDs. The objectives of this study are threefold. Firstly, to have an in-depth analysis of the performance of the old system. Secondly, to develop an enhanced software application that will resolve the problems encountered in the old system. And lastly, to evaluate the level of acceptability of both systems applying ISO 9126 software quality metrics and to determine their significant difference in performance. The general objective of this study was to develop 6 version 2 or the enhanced student ID generator and management system. The specific objectives are: one is to extend the scope and functionalities of the existing system to address the identified problems. Number two, develop the enhanced student ID generator and management system. Number three, determine the significant difference of the software quality between proposed and the existing system in terms of efficiency, functionality, reliability, usability, and security based on ISO 9126. The problems encountered in 6 version 1 in terms of efficiency, slow searching of records or information, in terms of reliability, duplicate student records, periodic runtime errors, database anomalies, incomplete data validation. And in terms of functionality, absence of basic reports for the transactions, such as the number of transactions per day, number of printed IDs, tracking of claimants, no backup or restoration, background changer, and back printing not available, and manual students profiling. And in terms of usability, problem some buttons and icons are not properly organized. This is the paradigm of the enhanced system. The backend database is managed by MySQL Server, while the front end was developed in using Visual Studio. Other essential devices present are the e-signature pad and the ID printer. An online form was also integrated for easier collection of students' information, especially these times. Software development methodology. During the development of our system, the study adopted agile model. The researchers first looked into the detailed operations on each transaction and conducted observations and interviews with the users and students. Then, the collected data was analyzed. The research design. This study used developmental quantitative research methodologies from data gathering up to system development. Simulation testing and the interpretation of evaluation results. Evaluation. The first set of respondents consisted of incoming freshman students from the different departments. The second set was composed of 22 IT experts from the 2 colleges. The students assessed only the 2 ISO 9126 metrics, which are functionality and usability of the enhanced system, while the IT experts assessed the software quality of the old and the new system in terms of efficiency, reliability, functionality, and usability. Sampling method. Yamana's formula were utilized in determining the sample size of the students. The confidence level was set to 95% and a 5% degree of error. The respondents were composed of the first year enrollees of the college. Out of 2,393 freshman students, we determined 343 respondents. Statistical analysis. The collected data was analyzed using descriptive statistics in the form of frequency and percentage in the evaluation of the quality of the existing and the new system. Result and discussion. Result for specific objective number 1. In terms of efficiency, the solution was to enhance the query statements and adding value as parameters. In terms of reliability, backend database restructuring, and getting rid of illegal operations and improve data validation. In terms of functionality, essential reporting and backup and restoration functions, online form, ID background changer, back-to-back printing, self-profiling, and in terms of usability, improve button placement and feedback organization. And These are the results for specific objective 2. And for specific objective 3, in the assessment of the software quality of the two systems in terms of efficiency, the old system achieved a weighted mean of 2.42. On the other hand, the respondents rated the new system with a weighted mean of 4.47. The notable difference between the two systems was about the response time of the user's query. As for functionality, respondents rated the old system with a weighted mean of 2.33, while the new system was rated with a weighted mean of 4.5. The reliability test result confirmed that the old system's processes are not stable enough to be a reliable software for ID generation and management. The respondents had an overall rating of only 2.34, which means they disagreed that the old system process these criteria for reliability. On the other hand, the reliability test result of the new system showed that the respondents agreed on all the given criteria for reliability, having an overall total rating of 4.23. For the usability rating, experts rated the old system 3.97, while the new system was 4.6. The overall usability rating was particularly on the user's interface, expressed that there's only a slight improvement in the new system. In terms of efficiency, the overall rating of 4.31 implies that this new system is working efficiently. In terms of usability of the online profiling form, the new system passed the usability test with a weighted mean of 4.36. It can be gleaned the difference in the performance of the two systems in terms of efficiency, functionality, reliability, and usability. The results of the comparative evaluation revealed that the new system had significantly improved over the old system in terms of efficiency, reliability, and functionality. On the usability criterion, however, it was determined that the performance difference between the two is very minimal and deemed insignificant despite giving a higher rate on the new system by the IT experts. Conclusions and recommendations. In this study, an ID generator and management system was enhanced to improve the process of generating and managing electronic IDs for students. An online student profiling was integrated to the enhanced system to avoid no queue of students due to manual profiling process. To evaluate the software quality level of both the old and new system, they were both rated by experts using the ISO 9126 software quality standards. Based on the results, the old system generally did not meet satisfactorily the criteria on efficiency, functionality, reliability, and usability. On the other hand, the new system met a good software quality standard when evaluated by the respondents. The comparison between the new and old system performed by the expert revealed that there is a significant improvement in the new system over the old system in terms of efficiency, functionality, and reliability, while there is no significant difference in the two systems in terms of usability and particularly on the user interface. At the same time, the students' evaluation of the new system revealed that the new system passed the software quality standards in terms of efficiency and usability. The new system can be extended through a provision of additional system features such as back-to-back ID printing and improving resiliency in terms of data loss or system errors. Thank you very much. That's all. Thank you.
Yes, thank
Thank
you,
you.
Bang.
Thank you.
Yes, so any questions?
So, up till now, what are the limitations you find in this system? Any improvement?
I'm sorry, I can't understand.
Limitation. What are the limitation?
Limitation of
Limitation.
the limitations of the system, ma'am.
Limitation.
Sorry, ma'am, I can't understand.
Okay, fine. Thank you.
Okay, thank you, ma'am.
Okay, any other question?
Peng, I wanted to know why did you select only these quality attributes?
Because those are the only improvements of the new system. And
Isn't maintainability an important attribute to be measured?
yes, ma'am.
Never mind, that's okay. Yeah. All the best.
Okay, thank you. Thank you, Peng. Now we move ahead with our next presentation. It will be by Abhishek Deshmukh. He will present a paper on violence detection through surveillance system.
Yes, I hope my presentation is visible.
Yes, yes.
Okay. So good afternoon to the respected panel members and other authors who have joined this presentation session. Myself, Abhishek Deshmukh, and my co-authors are Yash Pente and Kshitij Waram. We are the final year students from the Department of Information Technology, and our guide is Dr. Nilesh Marathe. Um, so this is the overview of the presentation, like how presentation will go forward. First, we have introduction. Then we have literature survey, where I have made a table of 3 papers that I have surveyed. Then the third is proposed methodology. Fourth is analysis. Fifth is results. Then conclusion, and then future scope. Okay, so introduction. Over the years, the instances of public violence have increased. There are CCTV cameras installed, but the CCTV cameras require constant human supervision, and hence they are prone to human error. The project aims to deliver a system which automatically detects violence in the crowd, and we have used deep learning models like convolutional neural network and recurrent neural network to detect violence and alert the local authorities. Literature survey. As you can see in the first paper, they have experimented with 3 models. The first model was CNN, the second model was LSTM, and the third model was is LSTM and CNN combined. So transfer learning was used to train the models. The merit was found at adding a CNN layer in front of the LSTM layer improves the accuracy of the model. Now in the second paper, body sensors were used to collect data, and CNN was used to detect activities such as cooking, bathing, sleeping, etc. Now the merit was that the training time required by only CNN is much lesser, and the demerit is that only simple activities like cooking, bathing, etc. could be detected. In the third paper, CNN was used to extract features, and LSTM was used to establish the temporal dynamics. And the merit was that the proposed architecture, which is the CNN and LSTM combined, it produced better results than the only CNN architecture. But the demerit was that it required 20% more time than the baseline CNN model. Now we have the proposed methodology. So our system basically can be divided into 3 parts. The first part right here is to convert the video into frames. Then the second part of the system is to extract the features from the frame and to break them down into activation maps. This is done over here by the VGG16 model. And the third part is to analyze the sequence of those frames or features that we have and to find out if the video contains violence. And this is done by the LSTM network over here. Okay, so now the proposed system will obtain the footage from surveillance camera to begin with the process of analyzing. The context of a video cannot be learned over a single frame. So this means that we cannot use one frame of the video to determine if the whole video contains violence or not. Therefore, the system needs to analyze a sequence of frames where each frame will add to the context of the next frame. Now each frame is extracted at an interval of 0.2 seconds. So in 1 second, we have 5 frames. Now, as I said earlier, that multiple frames needs to be analyzed together. We analyze 3 seconds of the video at one time, then the next 3 seconds, and so on. Hence, we have 15 frames for 3 seconds, which are analyzed at one time. Now, as discussed earlier, the frames are extracted from the video. Then the obtained frames are passed to the VGG16 model. So VGG16 is a CNN model, and it consists of 16 layers. So when a frame is passed to the VGG16 model, the model performs convolution on it, and it uses techniques like max pooling and activation functions to extract the features from the input frame of the video. Thus, we have a group of 15 transfer values corresponding to the 15 frames. The last layer of the VGG16 is removed, and the output of the penultimate layer is given as input to the LSTM. Now, to analyze the video, to analyze if the video contains violence, each frame needs to add context to the next frame. So for this very reason, we have used LSTM, which is a special kind of recurrent neural network. They are composed of memory cells and they have 3 regulators. They also have feedback connections. So the memory cells and feedback connections enable them to form long-term dependencies between the multiple frames, and hence they can determine the presence of violence in a video if there is. Then the group of transfer values are given as input to the LSTM. The LSTM will calculate the violence and non-violence score of each frame. Now, transfer learning is used to train the model. So what transfer learning means is basically storing the knowledge learned while solving one problem and then applying it to a different but related problem. And transfer learning assures that the accuracy of model stays high. Then finally, if the video is classified as violent, an email having the frame of the video is sent to the respective authorities. In this way, the authorities are intimated that violence is taking place. Now is the analysis part. So our data split, we split the data set into 70 and 30%, 70% for training and 30% for testing randomly 4 times. So which means that we had 4 permutations of the data set. Then the whole model was trained and tested on the corresponding 4 data sets. Then we chose the model which gave us highest accuracy and took it further. So now for each frame, a violence score and a non-violence score is calculated. The threshold value for violence score was 0.5 at the start. Then later we changed it to 0.7. So if the violence score of the individual frame is greater than threshold, then the frame is classified as a violent. And in this way, if a violence is detected in 5 of such frames from our 15 frames, then the video is classified as violent. After testing, the confusion matrix was prepared and the accuracy was calculated. So here is the screenshot of the confusion matrix where you can see all the true positive, false positive or the true negative values, and the accuracy came out to be 91.57%. Okay, so these are some screenshots from the working of our system. As you can see here, we are testing a frame from the video. So this frame is basically from the game ice hockey, where the players of both the teams got into a fight on the field. And in this image, you can see that different frames were created and violence and non-violence score is calculated. And when the 5th frame is detected to have violence in it, we have a notification that mail has been sent. And now this is the actual mail which will be sent to the authorities, and it also has the frame from the footage where the violence was detected. So yeah, to conclude, I'll say that the system uses a combination of CNN and RNN models. The footage from CCTV is sent to the system, where system extracts a frame at every 0.2 seconds. The authorities are intimated about violence through email, and the system is computationally light, so it can run on a single GPU as well. And currently, the scope of the project is to only detect fights or brawl situations in the footage. Okay, for future scope, the system can be further improved to detect different violent or crime activities like robbery, public shooting, etc. And while working with live feed real-time data, the model should be able to process the data captured with some acceptable amount of delay. Yeah, so thank you. That's it from my side.
Okay.
I had a question. Like you said that in case of an alert, the email would be sent, right?
Yes,
So
ma'am.
if it is an alert, it is an alarming situation. And do you feel that responses to email will be made quick in comparison to the other ways of intimating the person concerned? like sending an SMS or a call?
Yes, ma'am. Like absolutely, there are other ways where
I
we
mean, the failure rate or the reliability rate of sending and receiving and responding to emails.
Yeah, yes, ma'am. Like there are absolutely other ways like calling or messaging where our alert can be like quickly heard by the authorities. But as it is a computer system, I think like recording a call and like doing intimating the authorities via call would be like a little bit difficult, or we can do that at a later stage. But yeah, instead of email, we can surely send text messages
Yeah.
to the authorities.
Okay. Yeah. Thank you so much. Nice presentation.
Thank you, ma'am.
Nice presentation.
Okay, thank you.
Thank you.
Yes, quick reaction. Yes.
Can I stop sharing the slide now?
Yeah.
Okay.
So uh, thank you, Abhishek. So we have with us as our next presenter, Otto Royce. So he will present on new horizons for application of micro algae in the national economy. Yes, Royce. Now you can share your presentation.
Yes.
Yes.
I hope you can tell.
Yes, your voice is audible, and yes, we can
So
see your presentation.
you
Yeah.
can see, yes. Good afternoon, ladies and gentlemen. My name is Otto Royce. I'm the CEO of Austrian company, which is called Röhren und Pumpenberg Bauer. Maybe some of you have already heard from us. I think I'm the only one not from Asia, so for us, it's still a little bit in the morning. Hello to Asia, hello to India. I want to show you a little bit about what we do. We do a lot of cooperation with universities. In this case, particular with the Technical University in Russia, in Volgograd, and with the Technical University in Austria, here in the city of Graz. When we look to our beautiful planet out from the space, we can see it blue, and this beautiful picture, this beautiful blue color is mainly coming from the big part of water on our planet. And as big as the quantity of water is on our planet, as big is also the importance of the water. And it's very important that we use it and keep it as clean as it is, and that we use it and don't waste it too much, because in many areas of the world, particularly in Asia, the resources are very limited, and we already have a big influence of the lack of water on different areas, particularly, of course, in agriculture and in drinking water supply for many people. So we can hear from many people in big congresses or wherever. We have to be very careful, because the resource, this water resource, also has an enormous influence on our food, on the nutrition of the people on this world. And as we all know, the population is growing. We see pretty clear forecasts for the population of the world, of the earth. It will probably grow in the next 30 years up to 9 billion people worldwide. And of course, we have to give food to all these people. That means, in comparison to today, we have to feed nearly another billion of people, what is an enormous, enormous quantity. And it's absolutely clear that the only choice to do this is that we produce food on irrigated agricultural land. That's absolutely clear. There's no chance otherwise to feed so many people. This issue, of course, is also very well known by United Nations, and they think a lot about these things, and they also tell us that we have to think absolutely big to solve this problem and to prepare everything what we need. And coming to that, we see that the algae will probably play a significant role in future in the complete process, as well in food stuff production, and also in the complete area of agriculture, and will have an enormous influence also on our water. What we eat, of course, has the population and the mentality of people will have a very big influence on that. And so in the University of Austria and in Volgograd was done a study how this so-called Generation Z, which is now around 15 to 30 years old, how they will make their decision what they are going to eat, and what is going to influence on that. And we clearly could find out that there is a strong trend towards new things as these algae, and there are these microalgae, and there are already now a couple of them, you can see it on the folia, already allowed, agreed to be nutritions, which should have very positive influence on our life, on our body, and on our health. Of course, what is always very important for these things, what is the chance, or what are the options to make so more or less new things? It's of course a very big question of the potential, and we try to figure out the economical chance or the economical potential for biotechnological processes to fulfill the quantities needed to have a significant influence on nutrition and also on the quality of the water we have on the earth. And as you see on this figure, it is really enormous, the potential. It's guessed to go up to 500, 600, 700 billions of dollars per year to be such a big business. But it is, of course, pretty new technology, and it's very important that this Generation Z, as it is called, is interested in that and is going to do this. We have here shown a little bit what these microalgae, what is the potential of one species, this Corella vulgaris. Yeah? You see, it is a very small animal. It's only a diameter from 2 to 10 microns, but it can do a lot. Yeah? It can assimilate solar energy. It produces oxygen. It contains around 45% protein, 35% carbohydrates, and around 10% omega-3 fats and acids. And this is very important because of this wide range. We can use it for many things. We can use it as well for water clearing. We can use it for nutrition for animals as well as for human beings, and that will have, of course, a very big influence. We also can bring it in natural waters. We can bring it in pretty warm, more or less standing waters. We can put it in moving waters in sweet water as well as salty water, and it will have a marvelous influence on the quality of the water, and also it will have a big influence on the animals living in the waters as fish or etc. It's also already for years confirmed this effect by different universities. They give awards for that, and it's also in some areas already patented to do it. What else we can do with these algae? We can put them, for example, into irrigation water or into manure, which is used as fertilizer, because it has excellent influence on the quality of the soil. So it is a very good add-on on water or manure, for example, or also other fertilizing liquids. Another very important issue because of the attitudes is it's possible to use it for lights. You can make light poles or whatever in cities, for walls, for big buildings, where we need now a lot of electricity. We can use it instead of that. And it's also possible to produce biofuels, which of course would have significant positive influence on the world climate. To show you a little bit what we are doing, we are working in these fields, in both fields, in the freshwater, in irrigation, but also in slurry management, in wastewater management, and in both of these fields, this algae can be used and can have extremely positive influence on everything. Up to now, we are already irrigating more than 3 million hectares of agriculture land in the world, and that significantly will be more in the next 2 decades, even only through the growth of the population. In the two pictures here, you can see the main factory in Austria where the machines for these things are produced. And on the left side, you see a little bit about our spray over the world. We have 20 daughter companies in many countries of the world, at least one on every continent. How important it is to use the water very efficient, I think we all know, and it is of course also a particular issue to use as few water as possible, because in many areas we have to stretch the quantity of water which is available over the entire growth period, what is not so easy. But for this, many technologies and machines have been developed in the last decade, and they are completely controlled by electronic systems working more or less automatic, if it is wanted, by the farmer. And we have all the options to for remote control of the systems by handy mobile phones, or also by computers or tablets, of course. There are a couple always of important issues to be taken care of. The main issue is always to measure or to know what is the actual need of the land for water, in which position is the equipment, are the machines, are they ready, or what has to be done to make them ready. And then it is to let the machines go out, let go them more or less automatic, and spray the water. And in the best case, which also with these algae, because they have extreme positive effect on the soil, and of course to stop the complete systems when the job is done on the fields. So, we have maybe a change in our behavior of nutrition We had it centuries, like in the upper picture, that we more or less eat fruit, vegetables, meat, or we change into a much more modern way of nutrition, which has a lot of molecular parts on it. But nevertheless, it doesn't play any role. However we do the first, the second version, or a mix of both, we always need to produce the fundamental products. And for this, we all have a big task in front of us to use water, to be very careful with it, and to use additional things as, and a good option are these algae, to make it much more productive, much more healthy for all the population. So that was in a very short version to show you a little bit what we are doing and what we think is very important for the future, because I'm absolutely sure, and we hear it in all big conferences, doesn't matter from whom, United Nations or whatever, they always tell us we have to think very big all together without any borders to solve these important issues for the well-being of the mankind in the next 2 decades. Thank you very much.
Thanks a lot. It is really a nice presentation, and the thinking behind it is really good for the society as well as the nation. Yes, anyone has any questions? Please.
No, sir, no questions. Very nice presentation, sir.
Thank you very much, madam.
Okay, thanks a lot. Thanks a lot. So we move ahead with our next presentation, and yes, this presentation deserves a good reaction, right? So thank you. Reaction, yeah, thank you. So we move ahead with our next presentation. The next presentation will be presented by Rupa, and she will present on social interaction enabled industrial Internet of Things for predictive maintenance. Yes, Rupa, you can share your presentation.
Can you see my screen?
Yes, but right now it is Zoom. You can go towards the presentation slide. Your voice is audible, and just show your presentation.
Just a second, just because I had a problem with my laptop. That's the reason I took my mobile. Just a second.
Yes, perfect. Perfect.
Yeah.
Perfect. It's fine. It's fine. Yeah.
Thank you.
Okay.
Good afternoon, everybody. This is Rupa here from Bangalore University. I'm a research scholar, full-time research scholar at University Visvesvaraya College of Engineering. Today, I'm here to present my research work on social interaction-enabled industrial IIoT, Industrial Internet of Things for predictive maintenance. Before I start with my presentation, I just want to give you a brief introduction about what is social interaction-enabled industrial Internet of Things. So as all of us know, what is IoT? IoT refers to a rapidly growing network of connected objects that are able to collect the data, process it, and exchange the data without any human interference. So according to Cisco, they predict that there will be more number of devices connected than people. So what is SIoT? Since there is a huge number of devices getting connected every day to the internet, one of the major issues that arises in IoT is the scalability issue. In order to overcome this issue, a new paradigm is coming into existence. That is social Internet of Things. That is called the SIoT concept. So this SIoT concept, so SIoT establishes a similar to the social media, like how we establish a friendship relationship. Similar way, uh, among the objects can also establish a relationship. For example, I'll just give you a simple example over here. Just see a smart home. In the smart home, object can establish a relationships. For example, a parental object relationship. If the objects are manufactured by the same company, then the manufacturer, then they establish a parental object relationship. So this is SIoT. In social Internet of Things, object establish a relationship among themselves. So similarly, co-location. If they are located in the same location, then they establish a co-location. These are the definitions what we have given for a relationships. A co-work. If they work together, if the objects work together to perform certain relationship, then it is a co-work object relationship. Social object relationship. If they often, if they more frequently they perform, they meet each other to perform certain tasks, then it is a social object relationship. These are the relationships which I have defined in my survey paper, which has been published in Elsevier Computer Communications. Continue with this work, I have introduced this SIoT concept into industrial Internet of Things. So social Internet of Industrial Things, so that is the convergence of SIoT concept into industrial Internet of Things is what is called as a social Internet of Industrial Things. So in this SIoT concept, I'm introducing, I just want to use a predictive maintenance. So this is the agenda of the work. This is the outline of the proposed methodology. First, initially, I'll just tell you what is predictive maintenance, then the background work, the proposed architecture for PDM SIoT, then the case study, the social relationships which we have defined for SIoT, the results, future work, and the references. So as my title says, social interaction enabled industrial IoT for predictive maintenance. So what is predictive maintenance? Predictive maintenance is, as the name says, it is just to predict if a failure is happening in some system or something. So similarly, predictive maintenance in industrial Internet of Things is to identify the failure before it could occur. So that is to lead it actually reduces the maintenance cost and also the machine downtime if we go with the predictive maintenance in industrial IoT. So predictive maintenance mainly relies on mainly on sensors, the sensor which has been embedded on the machine and which is able to detect the critical piece of machinery if it is close to failure. That is predictive maintenance. So these are the few works which has been background. That's a literature review work which we have carried out. There are n number of approaches which has been done for predictive maintenance. The first one is the manual analysis. Along with the drawback, I've just listed out the drawbacks of the various methods of existing approaches for predictive maintenance. In the manual analysis, it is always depends on the team. And the second one is a computerized maintenance management system. It always, it does not provide a statistical analysis. The virtual physical twin, the virtual statistical twin. So it is not scalable to the many of the devices. The assisted machine learning system, it should always be operated with an expert. And the autonomous system, it leads to an ambiguous decision. So in order to overcome these issues, this motivated us to come up with a new social internet, SIoT-based predictive maintenance in industrial settings. So this is the proposed architecture. As you can see, there are 3 layers. The first, the base layer. The base layer is a manufacturing assets, which consists of manufacturing assets. It is machinery parts, which is embedded with the IDs, sensors, actuators, such as RFID tags. You would have heard about this in most of the IoT devices. And the second layer is for the network layer, which is used for the connectivity to cellular networks, especially for the internet. Since it is the internet IoT, we need a network layer. And above that, there's an application layer. And application layer has 2 sub-layers. The one is the interface layer and the SIoT component. This is an important constituent of the proposed architecture is this SIoT component sub-layer, which has the relationship management and the social agents, which helps to communicate among the objects. So there's a profile management in order to identify each and every object in the machinery. Every asset element, we need a profile management and data management. The semantic, in order to represent it, we have a semantic ontologies and we have a predictor engines. Under this predictor engine, we have two types of predictor engine. One is it is going to identify, it is going to find out the remaining useful life of the predictor. It is going to predict how long this machine element is going to remain, the remaining life of the machine. Okay, this is the proposed architecture. I'll just move fast because a lot of things is there to tell. The proposed PDM architecture is especially based on social relationships. So in order to implement this architecture, I've just carried out this architecture with a simple case study, a bearing. All of you would have heard about this bearing. A bearing is a machine element which is especially used in most of the machinery-based industries, which is used for especially for fixed axis in order to move the, in order to freely move the machine parts, either in a circular or a free linear motions. Okay, bearing. This bearing may fail due to numerous reasons. Maybe because of the overheating or overloading, improper lubrication, or excessive external vibration, or due to contamination. These are the few which I have listed. There are n number of reasons due to which the bearing may fail. Based on these failure, I have listed and written a few definitions for relationships for these failure conditions, such as torrid object relationships. Maybe because of the high temperature, if it fails, I just list the name as torrid object relationship. If there is a failure of such a high temperature, then who has to be intimated? So who's the repair person who we need to intimate it? So that is torrid object relationship. One more is false Brinell object relationship. Similar way, based on the condition of the failure, I've defined around 5 relationships: withered object, Defel object, coercion object relationship. So these are the relationships which I've defined, because SIOT mainly deals with the relationships, that is to communication among the objects. So after we define the relationship, I'll just tell you the implementation. We have implemented this work by using a node-RED simulation tool, which is developed by IBM. Since there is no, till now, there is no industrial environment has not been implemented completely in the real world environment. So we go with the simulation tool, that is a node-RED simulation tool, which is available of open source tool for prototyping the IoT applications. And these are the results which we have obtained along with the threshold I've defined for the temperature sensors. For this, I've used PHM dataset, that is a prognostic health management dataset of the bearing from the NASA dataset. For this, based on the temperature sensors, pressure sensors, we have defined a threshold. If it crosses beyond 400, so there's a temperature, because the bearing would have failed because of the temperature. So these are the threshold limits which we have defined for 5 different sensors: pressure sensors, vibration sensors, smart RPM sensors due to contamination which occurs. And these are the results, the alerts generated using a node-RED simulation tool, so which I've defined here at the bottom. As a future work, in order to, we have already to validate, to test this proposed system, we want to work on the real world industrial settings and emphasize the performance enhancement. In order to, we would also like to improve the performance of the system. Along with the controlling and management of the industrial setting, we would also like to improve the performance of the system. And these are the references. Thank you.
Yes, thank you, Rupa. Yes, question from the chairs?
No questions. Nice presentation, Rupa.
Thank you. Thank you, madam.
Thank you. Okay, thank you. If anyone has any question to Rupa, you can write into the chat box, so she will give answer, or you can share email address if you like any presentation, or if you want to connect in the future with the author. So definitely you can write into the chat and you can connect with them. So we are moving towards our last presentation. That presentation is by Subhangi. Subhangi, please share your presentation. The paper title is Privacy Preservation for Data Sharing with Multi-Party Access Control in the Cloud Computing, a review paper. Yes, good. Subhangi, you're not audible. Subhangi, your voice is not coming. Please check your connection. Hello. Hello, Subhangi.
Hello.
Yes, now we can hear you. Please start.
Um, Hello, sir. Here's Shubhangi. Good. I'm the.
Yes, please, and please make it quick, and please try to conclude in 7 to 8 minutes,
Yeah.
please.
Okay.
Thank you.
My research work towards the privacy preservation for data sharing with multi-party access control in cloud computing, a review paper, which is presented by Shubhangi Khot, and the co-authors are Manjrekar and Deshmukh. So let's quick start with the introduction. What is the cloud computing? Everybody knows the basic concepts of cloud computing. The cloud computing is the combinations of various services like server, storage, databases, which give the fastest intelligence or flexible access to our users. Then we see the what is the cloud service provider. There are lots of providers like Google, Amazon, Alibaba, where the user can store their data securely. Then the privacy preservation for secure data group sharing in cloud. Here one scenario where the users share their data and store on the storage server. Then there is one data provider which has the encryption and uploading and all these rights for that. When user have also the key authority in that system, so that key authority gives the key management to the users and also data provider, and with that key exchanges, all the storing of that data is done here. Here we are for this paper we have some summary related to literature survey. I have concluded 5 papers where the one Mona system, then access control based paper, where the ABB, IBB, CPAB, these schemes are related. So for my paper, I used this. So this is the different cryptography schemes where the ABE, that is attribute-based encryption key, which is introduced in 2006. Then this one is the PRE, proxy encryption key, which is introduced in between 2000 and 2007. IBB, which is also in 2007, and the CPRE, which is the extended version of the PRE scheme. That is the attribute-based encryption key, where we focus on the attribute encryption key, that is